definitions. Pharmacodynamics means what the drug does to the body. We are taking the drug to fulfill certain purpose, to cure certain pathological condition, to achieve that function. What is the goal of action of the drug? What is the principle of action of the drug? What is the mode of action of the drug? Or what is the mechanism of action of the drug? That part we will discuss or covers under pharmacodynamics, which merely means what the drug does to the body. First comes to the point, principle of drug action. In principle of drug action, the first principle is the stimulation, then depression, then irritation, then replacement, then cytotoxic action. Stimulation means selective enhancement of activity of certain system or selective increase of activity of certain systems. For example, best example is CNS stimulant. All of you know the term CNS stimulant. Caffeine is CNS stimulant. Amphetamine is CNS stimulant. When athletes are taking amphetamine, their activity are increased because it stimulates CNS. Then another principle of drug action is the depression. Depression means it is the opposite of the stimulation. Means diminution or decrease of property of the body. In certain time when a pathological condition exists due to hyperactivity or overactivity of a substance, at that time it needs to render or subside the activity. That comes under depression. Again I am giving the example CNS depression. Suppose a person is hyper-excitatory activity or hyperactivity or hyper-dopaminergic activity. At that time it needs to subside the systems. In that case, a CNS depressant is given. Certain people, they are affected by insomnia, means sleeplessness. In that condition, CNS depressant are given or sedative drugs are given which aims to depress central nervous system. When CNS depressed or the functions of depression is cure a particular problems, that is also comes under depression. Then irritation. In sometimes irritation is a property or irritation is a principle by which certain drug act and cure certain things or cure certain unwanted or pathological systems. For example, your bitters. Bitters, they irritate. They irritate by irritation. They increase the salivary secretion which directly or indirectly associated with digestion. Bitters irritate, as a result saliva secretion of saliva is increased. Then another important is replacement. Very good term is replacement. All of you know replacement is a term you might have seen cricket. Suppose a player, suppose Dhoni is injured. In place of Dhoni, another player is replaced. Just like that. If inside your physiology a biochemical substance or a biochemical entity is absent, in that case externally that agent is given. That comes under replacement. For example, levodopa in case of Parkinsonism. All of you know Parkinsonism is a disease associated with dopamine turnover. When dopamine level is decreased, Parkinsonism exists. To counteract Parkinsonism, levodopa is externally given. That comes under replacement. Another example is insulin in case of diabetes, type 1 diabetes. Because insulin is associated with carbohydrate metabolism, when inside the physiology there is no insulin, at that time external insulin is given. That comes under the principle replacement. Then come to the next point, cytotoxic action. Cytotoxic, cell toxic action. You might have astonished. How toxic action is a principle of drug action? Yes, toxic action is a principle of drug action where it needs to toxify or destroy certain cells. That comes under cytotoxic action. The best example is anti-cancer drug. You know cancer exists due to over-proliferation of cells or tissue. In case of cancer treatment, the chemotherapeutic agent, they aim to kill or destroy the cell. The radiotherapy aims to destroy the cell. That comes under your cytotoxic action. Okay? Then we will come to mechanism of drug action or mode of drug actions. Inside the body, drug needs or drug combats with certain kind of mechanism, certain kind of substances, certain kind of paraphernalia, and by which it acts. The first things I would like to discuss, enzyme. All of you know enzyme from your +2 biochemical reactions, not only drug reactions but also general biochemical reactions, they are carried on under the influence of the enzyme. So enzyme is a vital parameter inside the body. See, this is the enzyme. You might have known luck and key theory. This is the substrate. Suppose it is a drug, it is an enzyme. This substrate activates the enzyme and it fulfills a biological function. These are the inhibitors. Suppose we aim to inhibit that enzyme because overactivity of the enzyme creates certain problem. In that case, these are the inhibitors. They what happen? Inhibit the enzyme activity or destroy the enzyme activity. Come to the next most important mechanism of drug action is ion channel. Protein which participate in ionic movement, they are responsible for transmissions of signal, transmissions of certain kind of ion related channels. So ion channels is an important tools for participating in mechanism of drug action. In short, I am explaining you. Suppose it is the biological membrane. In biological membrane, it is the ion channel. Let's take an example of sodium channel. Suppose it is a sodium channel. It is the biological membrane. It is under the biological membrane. Sodium channel is upon the biological membrane. See, I mean, operations of ion channel. Sometimes it needs to close. Sometimes it needs to open. Is a mechanism of drug action. For example, when there is excessive sodium efflux, then excessive action potential generation is there and excessive hyper excitatory activity is there. In case of epilepsy, what happened? The sodium gate of sodium channel is open frequently. In that case, it needs to close the channels. Means drug or anti-epileptic drug, they close the channel, means they prolong the opening of ion channels, sodium channel. Means they prolong the opening of sodium channel, they have a control over sodium efflux and they cure a particular problem, that is epilepsy. Just like epilepsy, many diseases are there. Either they are due to high flow of iron, in that case close the channels, or due to deficiency of ion channels or deficiency of certain iron. Let's take an example of insomnia patient. Okay, in case of insomnia or sleeplessness, what happens? Sedative drugs are given. What the sedative drug does? These sedative drugs, they are responsible for opening of chloride channel by enhancing GABA activity. These are sedative drugs. They stimulate GABA or they enhance GABA activity. Due to enhanced GABA activity, the chloride channel opening is frequent and chloride ion efflux are there. Due to high efflux of chloride ion, the cell get hyperpolarized, difficult to depolarize and sedation comes. Means it is a property. Means operations of ion channel is one of the important mechanism of drug action. Many more examples are there related to channels. I am giving another example. Blocking of sodium channel peripherally. Blocking of sodium channel peripherally. It is the mechanism of actions of local anesthetic. Means when we are giving local anesthetic for minor operation, what the local anesthetic does? The local anesthetic block the nerve conduction by blocking the local sodium channel. So perception is abolished in certain area and it lasts for up to half an hour or 45 minutes during the minor surgery. Then the next important mechanism of drug action is through receptors. The term which comes much more time in your pharmacology, that is receptor. Receptors are macromolecules. They are protein in nature. They are residing in effector cells. What they do? Certain drugs, they cannot work through enzyme, through ion channels, through other paraphernalia. They are extensively bound to receptors. Their tendency to bind with a macromolecule, that macromolecule is called as receptor. Drug combine with receptor and become a complex, and that complex is ready for biological action or certain changing functions. I am giving the diagram. Suppose this is drug, this is receptor. When drug combine with receptor, it an example. What is the eligibility to wear a earring for a girl? There should be an ear and there should be an earring. If the girl has no ear, she cannot wear earring. If the girl has ear but no earring, she cannot wear earring. Just like that, drugs need a receptor. It makes a complex, DR complex, and that complex, after attaching to the receptor, after the tendency to attach with the receptor, after forming the complex, drug act and drug elicit a biological functions, and a particular, it cures a particular systems. There are many terms or much more terms, they are associated with receptors. Certain terms which are highly associated with pharmacodynamic process. These are ligand, agonist, another term is there, that is partial agonist. Here is partial agonist. Then inverse agonist and antagonist. What are the concepts? Ligand. Ligand is such a molecule which has selectively tendency towards receptor and it binds to receptor. Means ligand has a tendency or affinity towards the receptor, it binds to the receptor. Mind it. Kama kon it only binds to the receptor. That is ligand. Means it has selectivity. Then agonist. What is agonist? Agonist means any molecule which binds with the receptor and elicits certain function which resembles the physiological signaling molecules, that is known as ligand. Means your drugs are ligands. Why? Because it has selectivity to bind with the receptor. After binding with receptor, they elicit certain function, certain physiological change, certain biochemical change. That's why it is known as agonist. Your drugs are agonists definitely because they are responsible for eliciting certain biological functions. After taking a drug, it changes a system, it changes a biological conformation, biochemical conformation, it has some physiological signaling activities. Then partial agonist, simple, थोड़ा सा छोटा agonist से the agent which binds with the receptor and elicit some maximal response. Means this response is less than agonist. Agonist का power करो, आप power कितने कम, it is partial agonist. Then what is inverse agonist? It is important. Inverse agonists are those agents who bind with the receptor and act opposite to the agonist. Mind it. And act opposite direction to the agonist. For example, suppose agonist a direction में जाएगी, this is the direction of agonist. It is the direction of inverse agonist. Practical life example में देखें. Suppose one agonist decrease blood glucose level. Inverse agonist increase blood glucose level. Suppose one agonist decrease elevated blood pressure. Inverse agonist increase the blood pressure. Means it acts opposite to the directions of agonist. Then antagonist, the classical term. Antagonists are agents who blocks the action of agonist. In sophisticated word, antagonists are agents who blocks the receptor actions of agonist. You might have feel there is no therapeutic activity of antagonist because it blocks the action of agonist. No, it has certain therapeutical activity in certain case. Take an example of poisoning or suicidal case in which there is overdose of the drug. To terminate overdose of the drug, antagonists are given. What antagonist does? Antagonists go to the physiological system, they antagonize the receptor to which the previous drug is to bind. In that manner, they are helpful in treating poisoning case or overdose of the drugs. Okay? Then another thing associated with the pharmacodynamic process is the therapeutic index. Then what is therapeutic index? Mathematically, therapeutic index, you know, it is LD50 by LD50. Lethal dose 50 divided by effective dose 50. Then what is lethal dose 50? It is the dose at which 50% of animal population show lethal effect. Then what is ED50? It is known as effective dose 50. It is the dose at which 50% of animal population show effectiveness. By dividing ED50 by ED50, we can get therapeutic index. Okay. Then we will go for another term which is known as risk-benefit ratio. See the term risk-benefit ratio. What is risk-benefit ratio? The term conveys in therapy the estimated harm or the estimated side effect versus the expected therapeutic effect of a drug at a particular dose. That judge risk-benefit ratio under these circumstances, the therapeutic range may be selected. The therapeutic range means the range of the concentration may be selected. For example, suppose we are discovering a drug. Can we take that drug in 1000 mg? How we know in 1000 mg the drug is safe? We don't know. So, in order to know that, a estimation is there which comes under risk-benefit ratio. My dear students, all of you see the graph. This is the x-axis and this is the y-axis. In x-axis, this is log dose. Log dose means this is the concentration side, and this is the effect. It may be percentage of effect, or it may be any other parameter which effect is quantified or judged. See the graph clearly. So here, this line is the therapeutic line. Mind it is the concentration axis. This line is the adverse effect line. Then here, it is the minimum therapeutic effect. Draw the line means this concentration. Suppose this concentration is 5 kg. Suppose this concentration here in line is the minimum therapeutic effect. Means if you move leftward, suppose 4, 3, you cannot get the therapeutic activity. You know, to get therapeutic activity, the drug has certain availability range. Therapeutic range means below 5 concentration, the drug does not touch that therapeutic range. That 5 is the minimum therapeutic range. Then see, this is the maximum acceptable adverse effect. Means you can tolerate this amount of adverse effect under this concentration. Suppose this concentration is 20 mg. Suppose it is 5 mg, it is 20 mg. Means below 5 mg you cannot get the therapeutic activity. And above 20 mg, your body, your physiology cannot tolerate the adverse effect. It is the maximum tolerable adverse effect. In between 5 mg and 20 mg, repeating again, in between 5 mg and 20 mg, the dose is selected, and this range is known as therapeutic range. This range is known as therapeutic range. Okay? Then comes to our discussion, combined effect of the drug. Combined effect of the drugs means when we take simultaneously two drugs, either we observe synergism or antagonism. Then that is synergism or synergistic effect. Synergism means when two drugs are simultaneously given or combined, then one drug enhances the activity of other, or one drug facilitates the action of other. The term is known as synergism, the phenomenon is known as synergism, the activity is known as synergistic activity. It is again subdivided into two types. One is additive activity, another is supra-additive activity. Then what is additive activity? Additive activity, in case of additive activity, the effect of drug A plus B is equal to the individual effect of drug A plus drug B. Here, when you add two drugs A and B, the effect is similar to the individual effect summation or summation of individual effect. It is known as additive. Then what is, let's give an example of additive. You can take in example aspirin and paracetamol. When aspirin and paracetamol are combined, it offers synergistic activity. Another good example is that nitrous oxide and halothane. When two drugs, nitrous oxide and halothane are being combined, it gives a better general and better anesthetic effect, anesthesia. So it comes under the example of additive. Then supra-additive. What is supra-additive? In this case, the summation of two individual drugs is greater than the summation of individual drug. ठीक है, आउ क्लियर को पहुंची in supraadditive case the effect of drug A individual drug plus the effect of drug B is greater than the individual effect of drug A plus the individual effect of drug B. See the minor difference. In additive, the effect of A drug plus the effect of B drug is just equal to the effect of A drug. But in case of supraadditive, the effect of drug A plus the effect of drug B is greater than when combined the individual effect of drug A with the individual effect of drug B. Okay, we can give a better example of supraadditive, that is acetylcholine and physiostigmine. Okay, then another example, a very good example is that the fixed dose combination of sulfamethoxazole plus trimethoprim. Okay. Okay, let's discuss about antagonism. By definition, antagonism means when one drug decrease or abolish the action of another, they are said to be antagonistic. In antagonistic, the effect of drug A plus B is less than the effect of individual drug A plus the effect of individual drug B. Okay, usually in an antagonistic pair, one drug is inactive as such but decrease the effect of the other. Okay, then according to different classifications of antagonism, one is physical antagonism. Here, based on the physical property of the drug, example, charcoal absorb alkaloid poisoning and prevent their absorption, and this phenomenon or the principle is highly used in case of poisoning. Then next is chemical antagonism. By definition, the two drugs react chemically and form an inactive product. Example, KMNO4 oxidized alkaloids used for gastric lavage. Then many more examples are there. Another example is nitrates from methemoglobin, which reacts with cyanide radicals. Then the next antagonism is physiological or functional antagonism. It means two biochemical active substances present inside the body or physiology, one oppose the action of another. In this case, the two drugs act on different receptors by different mechanism but have opposite over each other physiologically. The best example is histamine and adrenaline. Means adrenaline antagonize bronchoconstriction produced by histamine. All the unwanted reaction of histamine can be antagonized by adrenaline. Another example is glucagon and insulin in case of blood sugar level. When insulin is given in high amount or chronic use, the level of blood glucose is decreasing considerably. At that time, to counteract this situation, it is necessary to given what? Glucagon. What is the role of glucagon? The role of glucagon is to increase blood glucose level to considerable level so that it antagonize hypoglycemia produced by insulin.
TP.
Then the next variety is receptor antagonism. Here, one drug blocks the receptor action of another drug. It is of two types. One is competitive, other is non-competitive. Then what is competitive antagonism and what is non-competitive antagonism, and what is the fundamental or basic difference between competitive and non-competitive antagonism. In competitive antagonism, antagonist binds to the same site of the receptor. In non-competitive antagonist binds to another site of the receptor. In both cases, the action is blocked, but in case of competitive antagonist, which site is occupied by agonist, that site is bound by antagonist. In non-competitive, receptor binds, antagonist binds and blocks the action, but not here. It is one side of the receptor, another side of the receptor binds and blocks. That is non-competitive antagonism. Another difference between competitive and non-competitive is antagonist resembles chemically with the agonist in competitive types. In non-competitive, does not resembles. Then another point is intensity of response depends on the action and concentration of the agonist and antagonist in case of competitive. In case of non-competitive, maximal response depends only on the concentration of the antagonist. Then the example of competitive antagonist is acetylcholine and atropine. The action of acetylcholine is being blocked by atropine. It is the example of competitive antagonist. Another example which comes under competitive antagonism is morphine and naloxone. Okay, the action or the overdose or the poisoning effect of morphine is being blocked by naloxone, which is the best example of competitive antagonism. In non-competitive antagonism, the example is diazepam and baculin. Okay, this is the examples which comes under your non-competitive antagonism.